Hello friends, welcome to the session on data structure. In this session, we'll be discussing about binary search operation in linear arrays. Linear search operation has a complexity of the order of n. It is okay if the value of n is less, but if n is very large, then the complexity will be very high, and therefore a lot of computer time will be wasted in searching the element. And therefore there is another solution to search the element in the array, and this solution is being recognized by a name called as the binary search. So as its name indicate, it is a binary, bi that will stand for 2, and in binary search what we will do is that we will split the array into the two parts, and this splitting goes on until we find the element, and that is the reason this searching operation is being called as a binary search operation. So in this session, we will discuss what we mean by binary search operation, what is the algorithm, and how exactly this algorithm works. So let us start the session with the question what we mean by the binary search. As I told you that in the linear search, we need to make a large number of comparisons, and the problem is huge when the number of elements in the array are large. In order to solve this problem, this method is being evolved, and this method is being called as a binary search. But whenever you want to apply a binary search, then the basic condition for applying the binary search method to the array is that your array must be a sorted array. If you do not have a sorted array, then you probably cannot apply the binary search method. So before you apply the binary search to any given array, it is mandatory for you to have a sorted array. In linear search, this condition was not there. In linear search, it is not necessary to have a sorted array. Sorted array means the array elements should be arranged in proper fashion. Either they should be arranged in increasing order or they should be arranged in the decreasing order. But for binary search, your array that is given to you must be a sorted array. That is, the elements of the array must be arranged either in increasing order or in decreasing order. Say for example, as shown in this window, I have been given an array where there are 7 elements. The first element is 1, the second element is 2, 3, 4, 5, 6, and the last element is 7. So the first element, this is my first pointer start, which will point to the first element. Then the element having the value 4 is my middle element, and the element having the value 7 is my end element. So these are the 3 pointers that are required in binary search operation: start, middle, and end. And suppose I want to search for an element having the value 5. So this I will call it as a search key. This is my search key. Now in the binary search algorithm, what is being done is that you have been given a sorted array. One can easily observe that all the elements are arranged in the increasing order. The first element is having the lowest value and the last element is having the highest value. Now what I will do is that I will see that if the value of key means the element that I am searching, is greater than middle or not. And if the key is greater than middle, then what I will do, I will shift the position of the start to the middle plus 1. Now our key is 5 in this case, in this example, our middle is 4, and therefore key is greater than the middle value 4, and therefore what I will do, that I will shift the start pointer from 1 to the 5. So as shown in this diagram, the start pointer is being shifted now to 5. Accordingly, the 7 will be the end and the middle will be shifted to the position 6. Now again, what I will do in the binary search, I will search for the key, I will check for the middle value. And if the key is less than the middle value, then what I will do, I will shift the end to the middle minus 1. So one can easily observe from this diagram that the search key is 5, which is less than the middle value 6, and therefore the end will be shifted to middle minus 1. Therefore all of these 3 elements, start, middle, and end, will point to the one element only 5. And now one can easily observe that the key value will get matched with the 5. The key value will get matched to the 5, and therefore we can announce the successful completion of the searching. So one can easily observe that in a given array of 7 elements, if we would have been used the linear search operation, there would have been 7 comparisons. But now in the binary search, since we are dividing the given array into half and then again it is divided into another half, you will find that the number of comparisons are being reduced to 2 only. So this is the advantage of binary search. When there are large number of elements, then the number of comparisons are reduced to a large extent, and therefore the complexity of the algorithm reduces and the searching time, computer time, is also reduced. So binary search will narrow the search area. Binary search, in every iteration, the binary search will narrow the search area so that we can easily find the required element. So as I said earlier that in the binary search, the value is being repeatedly checked in only certain part of the array, and the complexity of this algorithm is much less, and this algorithm is much faster than that of the linear search algorithm. So let us understand how we can write the algorithm for the binary search. In the step 1, what we will do is that we will assign a variable low equal to 0. You can assign either a value 0 or 1. High will be n minus 1 because there are n number of elements in my array. If low is assigned to 1, then high will be 1, n in that case. Now what I will do in the step number 3, I will check whether the low is less than or equal to high, and if it is there, then I will repeat the steps 4 to 6. If the low becomes greater than high, then I will stop the searching operation. Then in the step number 4, you will find that I will compute the middle of the array. The middle of the array can be computed by using this expression low plus high divided by 2. So whatever is your low value, whatever is your high value, both are added and then it is divided by 2 to compute the middle element. And then I will check whether the given element, this is my search element ELE, whether it matches with the middle value of the array. If it matches with the middle value of the array, then I will check out the location. I will check the location and then I will go to the step 7, and in the step 7 we will check that the element is being found at the particular location if it is greater than or equal to 0. And if it is not greater than or equal to 0, means if it remains 0, then in that case we declare the message that the element is not found. And if it is not the case, then means if the element do not match with the middle element, then what we will do, we will check again, is the element is less than a middle. If it is, then we will decrement the value of higher pointer by 1, otherwise we will increment the value of lower pointer by mid plus 1. So this is the way the algorithm works. So friends, now let us understand one simple example regarding this binary search algorithm, how exactly this binary search algorithm works in order to find an element in the given array. Suppose we have been given an array where the elements are 25, 30, 15, 5 and 32. So one can easily observe from this example that the elements of the array are not in properly sorted order. So before we apply the binary search algorithm to any array, it is mandatory for us that we should have the array in the sorted fashion, because if the array is not in the sorted fashion, then probably this technique will not work. Therefore, the first step that we need to do is that we need to sort out the elements of the array in proper ascending or descending order. So I will rearrange the elements of the array as shown in this slide. So the first element will be 5 because this is the lowest element, then 15, then 25, then 30 and then 32. So these are the elements. Now these are the elements which are arranged in sorted fashion, increasing order. Now I will have the 3 pointers. One is the start pointer, another one is the middle pointer, and the last one is the end pointer. So the whole array is being pointed by the 3 pointers. So start pointer will point to the first element, the middle pointer will point to the value 25, and the end pointer will point to the end value 32. Now what I will do, according to the binary search algorithm, we will check what is our search value. Suppose our search value is 30. Then in that case, we will check the middle value or the middle pointer value is greater than or less than this 30. Now, as far as this example is concerned, you will find that our search value is 30, which means it is greater than 25. Therefore, we will forget about the first part of the array and we will have a concentration on the second part of the array itself. And therefore, what I will do, I will move my now the start pointer to the position 25. I will increment my middle by 1 so that it will point to 30 and my end will be the 32. So, instead of now searching for 5 elements, I will search only in 3 elements. And now here one can easily find that this middle value 30 will get matched with this search element 30, and therefore we can announce the successful completion of searching. If this value doesn't get matched, in that case we may have a further division and then either we find it or we do not find it. Say for example, if my search element is something say 31, then in that case you will find that the 31 element is not present in the array, and therefore in that case we will have an unsuccessful completion of the searching, because in that case I will ultimately point all the 3 pointers to the same location middle value 30, and 30 will not get matched with 31, and therefore we will announce that the search element is being not found in the array. So, binary search is a very important searching technique because the number of comparisons in binary search are reduced. When we compare it with the linear search has n number of comparisons, while binary search will have only log of n comparison, which is much less than that of n. Thank you friends for viewing the session.